Hi everyone. Having looked at work under different conditions in our previous lecture, so we've seen work under condition of isobaric process. We've seen it under polytropic process. So we're going to look at a couple of calculations just to reinforce our knowledge. So the first question says a fluid in a cylinder is at a pressure of 700 kilonewton. Take note of that unit, kilonewton. It is expanded. It's also critical for you to take note of that. At constant pressure from a volume, so that will be the initial volume, V1 of 0.28 to a volume of 1.68 meter cube. So you can see that increase determine the work done. So looking at this, since it's a constant pressure, we know that it's an isobaric condition, isobaric process. And we've been given that for an isobaric process, work done equals PV2 minus V1. If we plug that in, pressure is 700. Remember, it's kilonewton, so we times 10 raised to the power 3 multiplied by V2, the higher one, the increased volume, 1.68 minus 0.28. If we multiply that through, we should have 7 times 10 raised to the power 5 times 1.4, giving us 9.8 times 10 raised to the power 5. And that should be, if you multiply out the units as well, that should give us Newton meter, which is same. Newton meter is equivalent to joule. So this is same thing as 9.8 times 10 raised to the power 5 joule. So take note of that. So that gives us 980 times 10 raised to the power 3. So we can say kilojoule, or we can write it as 0.98 millijoule. So take note of those units. So let's look at another question. This time around, it says 0.112 meter cube of a gas has a pressure of 138 kilonewton per meter squared. It is compressed. So previously we saw expansion. So this time around we are seeing compression. And also remember, it's not just about the compression or the expansion. You need to look at, is the pressure changing or not. So let's look at what is happening here. It says volume. Okay, it had a volume of the gas. We've seen that there's a volume of pressure that it is compressed to this. So that tells us so what this tells us that the pressure is changing. According to the law of this, determine the new volume. So this tells us that there's the pressure changes. As a change in pressure, there is a change in volume. So when we have that, it means we have a P1, we have a V1, we have a P2, we have a V2. So what does that tell us? We have an we have a polytropic process. So this is a polytropic process. So take note of that because we have those changes taking place. The second thing we take note from this equation is it says the law is PV. Remember, we have PV 1.4. Remember, we said our n can vary from 0 to infinity equals to C. So PV equals to C. So what this translates to is P1 V1, so this translates to P1 V1 raised to power 1.4 equals P2 V2 raised to power 1.4. So that's that, and what we're looking for is the new volume. We're looking for V2, right? So let's try and make V the subject of the formula. If we keep solving that, we have P1 over P2 equals V2 over V1 1.4, same thing as V2 over V1 equals P1 over P2 1 over 1.4. And from there we have a V. We can make, remember it's V2, want to make the subject of the formula. That's the new volume of the gas. V2 equals V1 P1 over P2 1 over 1.4, which results in V1. And then we have that. I'm sure you can do this easier on your calculator. P1 over P2. Remember, this is a square. This is a square root. P1 over P2. Moving on, if we solve, let's plug in the values. We have our V1, which is 0.112, multiplied by, we said from the previous page, that should be 1.4 square, so root 1.4. P1, that's our first pressure, the first pressure, which is 138 kilonewton. Remember, the two pressures are in kilonewton, so that's why we are not, and it's a division, we are dividing, so that's why we've not bothered to write times 10 raised to the power 3. So 138 divided by 690. So if we had put 10 raised to the power 3 up, 10 raised to the power 3 down, it would have cancelled each other. So that's why that is not there. So 0.112, that power again, 1.41 over 5. That should give us 0.112, 1.4, and that gives us 0.112 over 3.157, which equals to 0.355 meter cube. So I mean, it is evident from this that it's a compression. Remember the original volume, this was the original volume, 0.112, and now we've got 0.0355. So those are some of the things you watch out for when you do such calculations. Is it increasing? Is it decreasing? What does the question say? So should it be positive? Would the work be positive or negative? Will the work done be positive or negative? Those are the things you need to have at back of your mind. Remember, if it's compression, the work done is negative. If it is expansion, the work done is positive. Let's look at another example. So 0.014 meter cube gas at the pressure. So take note, we've got a volume pressure of 2017 kilonewton per meter squared. Expands, so it's an expansion too. So that means if you're looking at the work done, it should be positive. To a pressure, so we've got a new pressure. We've got a new pressure, 207. We've got a new pressure there, 207 kilonewton per meter squared. According to the law, PV raised to power 1.35 equals to C. Determine the work done by the gas during this expansion. So looking at this again, it's evident that we have a P1 V1, we have P2 V2. So that, and then we have our PV is raised to power 1.35 equals C. So it is evident that this is polytropic. It is polytropic process. It's a polytropic process, and it's just an expansion taking place. So from the previous lecture, the work done for expansion, so take note, this is expansion, it is not compression as we saw previously. So this is expansion, so the work done is given as P1 V1 minus P2 V2 over n minus 1. However, V2 is what you're looking for, and we also know that based on what we have here, we can also say that P1 V1 raised to power n, we know our n, but let's still put it so long, equals P2 V2 n. So let's make V2 the subject of the formula. V2 becomes V1 P1 over P2 1 over n. And then if we begin to substitute everything we have, if we begin to substitute, we have we know our V1, that's the first volume, that's 0.014. We have the first pressure, which is 2070. Again, we are dividing, so that's why we are not putting the kilonewton there over 207. If we add, it wouldn't make any difference. 1 over n. What is our n? 1.35. So if you solve that, we should be getting 0.014 times square root 1.35 10, and then we get 0.014 times 5.05. So remember, it's an expansion, so we should expect the volume to increase. 0.077 meter cube, and it's definitely an increase. Remember, this is where we started from, and then we ended up here. So we've got an increase in volume. So, but it's only a part of the question that has been solved. We need to solve the second part, which is the work done. We already have the equation of work done. Remember here, this is the equation of work done. So let's just plug in everything we have now. Since we have V2, let's plug everything in. W equals, we have P1, so we have our P1 V1 2070. This time around, we need to ensure, because we are not dividing by another P, so you need to put a kilonewton value there. And then we have the volume 0.014. That is V1 minus, for the other one, 207 times 10 raised to the power 3. That is the pressure times the new volume, 0.077. And then divided by n. What is our n? 1.35 minus 1. If you solve that, 10 raised to the power 3, 0.35, 29 minus 15.95 gives us 10 raised to the power 3, 0.35 times 13.05. If you solve that, it should give us 37.3 times 10 raised to the power 3. The unit is Newton meter. And if you remember, we talked about that earlier on. Newton meter is same thing as joule. So this is joule. Then it's, so we have 37.3 times 10 raised to the power 3 joule, which is also same as 37.3 kilojoule. So that is our answer. So we've seen an example under isobaric. So take note, this is a polytropic process. We've seen another polytropic process. We've seen an isobaric process. Let's look at another one, which is hyperbolic process. So let's quickly look at that example. A gas is compressed. So again, compression. So take note of this. If it's compression, the work done is what? Negative. Hyperbolically, so when it's compression, work done is negative. From a pressure and volume of this and that. So we have P1, we have V1 respectively to a volume of, so we have to a volume of this, we have another volume, so this should be meter cube, not meter squared. Determine the final pressure and the work done on the gas. So we're looking at P2, but obviously looking at this, we have, that means there is P1 V1, P2 V2. So this is even though it's an hyperbolic process, but generally it's still represented under the polytropic process. And also remember, under hyperbolic process, if we PV, your PV to C, your N is 1. So for hyperbolic, N is equal to 1. So based on that, we can say P1V1 equals P2V2. So on this is hyperbolic process. So whenever you're given a question, you need to identify: 1, is it compression? 2, is it expansion? And then 3, you also want to identify what sort of process are you dealing with: isobaric, hyperbolic, or polytropic, as we've seen. So moving on, let's make, so it's P that we're looking for, right? So let's make P, we're looking for P2. So let's make P2 subject of the formula. So P2 equals P1 V1 over V2. Let's put that in. P1, which is 100 kilonewton, 100 kilonewton per meter squared, 0.056 over 0.056 divided by 0.007 equals times 8. And then we have 800 kilonewton meter squared per meter squared. So you see that even though I didn't write 1000 there, it's here. So kilonewton per meter squared. So and then the work done. So we know for the work done under hyperbolic condition, the formula is work done at hyperbolic or under hyperbolic process equals PV ln R, which is same thing as, so that R there, which is called the expression ratio. That is what your R is. R is the expression ratio. This can also be rewritten as PV ln V2 over V1. This V is the same thing as the V1, is the original volume, of the gas. So we've got that. So let's plug in our values. So we have our P, which is the original pressure, which is 100 kilonewton. And then we have our V, original V, which is 0.056 meter cube, and then lane 0.007, that is the new volume. And then the new volume, since it's a compression, will definitely be lower than the original volume, 0.056. And remember what we mentioned earlier on. Since it's compression, what must we do? We need to add a negative. We need to add a negative to that. So it's essential to take note of simple details like this. So we had negative value. If you solve that, we should end up with minus 5.6 times 10 raised to the power 3 ln 8. Minus 5.6 times 10 raised to the power 3 times 2.079 gives us minus 11.64 times 10 raised to the power 3 Newton meter, which is same as your joule. Remember that. So this is same as your joule. And also remember, this is your kilo. So that means we end up with minus 11.64 kilojoule. So take note of that. So if you don't put the right thing at the end of the day, you've not incorporated the negative or the positive, you might get the same magnitude in terms of this, but the answer will be wrong. So that is why it is essential to check all those details. So the work done on the gas is 11.64. So this is showing us that the work done is the work what is happening is compression. All right, so see you again in the next class. All the best. Cheers.